Hello all, in today's lecture we are going to see about binary multiplier. What is binary multiplier? Binary multiplier is just like a normal multiplier, like how you will be doing a multiplication of any decimal number. Here again we will be doing a similar kind of multiplication, but the only difference is that instead of decimal numbers, here we will be making use of binary numbers. This is the only difference. Otherwise, the way how you are going to do the multiplication, the procedure, everything is going to be one and the same. There is no change in that. Clear? This binary multiplier is again an example of a combinational logic circuit. So in this lecture, we are going to see how to design this binary multiplier using combinational logic circuit. Clear? Let's start from the basic. So let's start with 2 by 2 binary bit multiplier. I'll explain you with an example first so that you'll understand better of how to do the multiplication process. And then we'll move on with a generic way and then we'll do the designing part. Is that clear? No. Let's take two numbers, let A be 1, 1 and let B be 1 and 0. Fine, let this be A1, A0, B1, B0. Clear? Now, we are going to do a multiplication of A and B. For A, see how many bits we have got? We have got 2 bits. And for B, we have got 2 bits. What does it mean? We are going to do a multiplication of 2 bits with this 2 bits. That is why it is called 2 by 2 bit binary multiplier. Is it clear? Now, do the multiplication. I am taking the same example here. For normal multiplication, how you will be doing a multiplication? You will take your leftmost bit. You multiply with this digit first and then you will multiply with this digit. Right? In a similar way, we are again going to do the same procedure. No change in the way how we will be doing a multiplication. Clear? Now, multiply this 0 with 1. You very well know anything multiplied by 0 is 0. So, 0 into 1 is 0. 0 into 1 is again 0. Clear? Now, what is the next step? We have to take this digit, multiply it with this number first and then with this number. Right? Now, do the multiplication. 1 into 1. 1 into 1 is what? It is 1. So, 1 into 1 is 1. Again, then do the multiplication of 1 with this particular number. 1 into 1 is again 1. Now we are done with all the multiplication process. What is the next step? We have to do addition. Do the addition. The last bit, it will come directly to your output. Right? Here, 0 plus 1. 0 plus 1 is what? It is 1. So do the addition. 0 plus 1 is 1. What have you done here? You have done an addition. Now, have we got any carry here? No, we have not got any carry. So, this number will be coming directly to your output. So, this is going to be my final output. So, what do you infer from here? There is no change in our multiplication process. The same way like how we will be doing a decimal multiplication, here again we are going to do the same kind of multiplication, but the only difference is we are making use of binary bits. That is the only difference. Apart from that, there is no change at all. Clear? Now, let's analyze our output first so that it will be easy for you while doing the designing part. Clear? Now, take the last bit. The 0, it is coming directly here. We are not going to change anything in that. Whatever value we have got here, we are directly taking it to our output. Right? So, no change in that. Coming to this particular bit, for this particular combination, here what are you doing? We have got 2 bits here and these 2 bits we are doing a addition. What does it mean? It is nothing but 2 bit. This is 1 bit, this is 1 bit. So we have got 2 bits. 2 bit addition. In combinational logic design, which circuit are you using for 2 bit addition? Half adder. You very well know we make use of a half adder for doing 2 bit addition. Here we have got 2 bit addition. So we are going to make use of a half adder. Right? Fine. Coming to this particular bit. For this particular bit, we didn't get any carry. But while designing a circuit, we have to design it in such a way that it is able to handle all the possible combinations. Right? That is what is called a good design. Any circuit, say for example, if we take a 2 by 2 bit binary multiplier, we will be designing only one 2 by 2 bit binary multiplier. And that circuit, we have to design it in such a way that it is able to handle all the possible combination of input to give your output. Only then that design is called a good design. Right? So here we didn't get any carry, but there are chances for other input combinations wherein we are getting a carry. So we have to consider that as well while designing. So in case if there is a carry here, then this again is going to be 2 bit addition. So for a 2 bit addition, which circuit you'll be using? You'll be using a half adder. Clear? So for a 2 by 2 bit binary multiplier, we'll be requiring 2 half adder for designing. Is it clear how to do the binary multiplication? This is just an example to show you how the binary multiplication works. Now, for designing a 2 by 2 bit binary multiplier, we will do the multiplication of generic terms so that it will be easy for you to design your circuit. Clear? Now, for A, what are their inputs? It is A1 and A0, right? And for B, what are their inputs? It is B1 and B0, right? Now, we have to multiply A and B. How do you start with the multiplication? You'll take the least significant bit and then multiply this particular bit with A0 first, and then you'll do a multiplication with A1, right? Do the same. A0, B0. First, I've done a multiplication of B0 with A0. What is my next step? I have to do a multiplication of A1 with B0. So, do the multiplication A1, B0. Is it clear? A1, B0 or B0, A1. Both are one and the same. AB is same as a BA. Both are one and the same. You can write any way. Clear? Now, we have done a multiplication of B0 with A0 here, B0 with A1. What is the next step? You have to take the next bit and then in a similar way, we have to do the multiplication. So, B1 with A0. Do the multiplication A0, B1. Now, after doing this, what is the next step? Do the multiplication of B1 with A1. So, this is A1, B1. Right? Now, do the addition. Here we are not going to do any change to this particular bit. Whatever value we have got here, we are going to take it to our output. Right? So take it down. It is A0, B0. Clear? Now, coming to this particular bit. It is A1, B0 plus A0, B1. Here we are doing an addition of 2 bits. So you need a half adder here. Right? Now, here it is A1, B1. If there is a carry, we have to consider that as well. So, in case if there is a carry, then we have to consider the carry part as well. So, accordingly, we have to do the design. So, for this again, we'll be requiring a half adder. Understood? Now, let's do the designing part. Now, what are my inputs? It is A0, A1. So, my inputs are A0, A1. And with that, I have to multiply B0 and B1. B0, B1. These are my other inputs. Right? Now, what is the first step? B0, we have multiplied it with A0. Right? Do the multiplication. B0 I have. With A0, I have done a multiplication. For multiplication, which gate you will be using? You will be using an AND gate. This is an AND gate. So, what is the output of this? A0, B0. With B0, we have multiplied A0. That is this. Clear? Now, what is the second step? With B0, you have to multiply A1. So, B0, I already have it here. With B0, I have to multiply A1. So, do the multiplication again. For multiplication, which gate you will be using? You will be using an AND gate. So, this is A1, B0. Clear? Now, we are done with multiplying the first step. What is your second step? With B1, you have to multiply. With B1, you have to multiply A0. With B1, you have to multiply A0. B1, I have it here. With B1, I have to multiply A0. A0, let me take it again. I am doing a multiplication here. So, what is the output? It is A0, B1. I have got this particular term. Clear? Now, what is the next step? With B1, I have to multiply A1. That is this term. B1, I have to multiply with A1. A1, B1. Clear? Now, this A0, B0, I am directly taking it to my output. So, this A0, B0, I am directly taking it to my output. Let it be S0. Clear? Let this term be S0. Fine? Now, A1, B0 and A0, B1. These two terms I have done an addition. So, what does it mean? I am going to feed these two terms as my input to your half adder. That is what it means, right? Now, what are the terms A1, B0? A1, B0 is here. with A1, B0, A0, B1, A0, B1. These two terms, I have to feed it as my input to my half adder. Is it clear? For a half adder, you very well know you have got two outputs for a half adder. One is your sum output, one is your carry output. Right? Sum output, I am going to take it as S1, and the carry output, I am going to take it as C1. So what is the output of it? The sum output, I am going to take it as my S1. This C1, I am going to feed it as my input to my second term. Is it clear? So whatever carry output I am getting, that carry output I am going to feed it to my next half adder. Clear? Now what is the input to this particular half adder? It is A1 B1 plus the carry of my previous half adder. A1 B1 I already have it here. The carry of my previous half adder is here. Let me take it. And these two terms I have to feed it inside another half adder. Clear? What is the input of this particular half adder? It is A1 B1 and the carry of my previous half adder. Is it clear? So for a half adder, here again you very well know, for a half adder you have got two outputs. One is your sum output, one is your carry output. The sum output, let me take it as S2, and the carry output, let me take it as C2. So what is the output of this? This is my S2, and the carry output I am going to take it as my C2. Clear? So my final output will have S0, S1, S2 and C2. Is it clear? This is how you will be designing a 2 by 2 bit binary multiplier. In case if they are asking you to design a bigger number, like if they are asking you to design a 4 by 3 bit multiplier or 4 by 4 bit multiplier, how are you going to design? From an examiner point of view, they will be mainly looking at how many gates you have used and how many adders you have used. There are certain formulas for it. I'll explain you the formula so that whatever might be the input combinations they're asking you to design, it will be easy for you to design your circuit. Now, let's take for this example itself. How do you decide on how many gates you want? That is based on your input. How many inputs you have? A has got 2 bits. B has got 2 bits. So the number of AND gates required is based on A into B. That is 2 by 2 bit. 2 by 2 is equal to 4 bits. So 4 AND gates will be required. That is 4 AND gates will be required. Is it clear? And how many total number of bits you will be requiring in your output? That is based on total number of bits. Output bits is equal to A plus B. That is 2 plus 2 is equal to 4 bits you will be getting in your output. That is S0, S1, S2 and C2. Clear? And how many adders you require? Here, since we have used 2 by 2 bit binary multiplier, I have used a half adder. This half adder can be replaced with a full adder also. You very well know, for designing a full adder, we require 2 half adders. So instead of 2 half adders, I can have 1 full adder as well. Right? So based on full adder, we will give the formula. The reason being, for higher bits, like if you want to do a multiplication of 3 bit or 4 bit, there you will be having 3 bit addition. Since here we have got only 2 bit addition, I have used a half adder. But with the higher number of inputs, like if you want to multiply a 4 by 4 bit multiplier, or if you want to multiply a 4 by 3 bit multiplier, if that is the case, you'll be requiring a 3 bit addition, 3 or more bit addition. Fine. How do you decide on number of adders? That is based on B minus 1. How many bits you have for B minus 1 will give you the number of adders you want. And this is your full adder. Is it clear? This is how you'll be deciding on how many gates you want, how many adders you'll be requiring and how many outputs you'll be getting. Clear? Whatever might be the input combination they're giving, take it to the generic form. Do the multiplication like how we have done it here and then take it to a design. Be sure of how many gates you require, how many output bits you will be getting it and how many adders you require. Just cross check it with the formula so that it will be easy for you. From an examiner point of view, these are the few basic things that they'll be looking into it. Is it clear? I hope you're clear with this lecture. Let's sum it up. In today's lecture, we saw what a binary multiplier is. We tried to explain it with an example and then we took the generic form of it. We tried to design this 2 by 2 bit binary multiplier, and for deciding the number of gates, number of adders and how many bits you want, we have given you the formula as well. Based on these formulas, whatever might be the input combination they're giving you, you should be able to decide. I hope you have understood this lecture. If you find my lectures useful and informative, please do like, share and subscribe to my channel. Thank you.